It sounds so convincing.
All right.
I saw it on TikTok.
Okay, you ready? So you guys like the Optimus Prime joke? Nice. I thought of it when I was like, okay, hey, so today's topic, listen, today's topic is called optimization. And I will say that I've sprinkled this in throughout the course and you didn't even know it. But these are like the hardest kinds of problems. In my opinion, these can be like the hardest types of problems in calculus. But you've already done some of them. Go you, right? Here's the thing though. Do you remember when I would tell you on the last test, find the minimum profit and the maximum profit, minimum cost, all that kind of stuff, right? That is anytime you find a minimum or maximum in a word problem setting, that is called optimization. Do you guys know what optimization to optimize something is? Get the best out of it, right? So if I want a minimum cost, that's like getting the best like cost to me. And so I am also not going to like dive into some of the super difficult ones that you'll see. Okay, you're welcome. I'm just going to add something else on to our profit stuff. And I will show you a distance one because that's pretty common. I was looking at my college calc book and notes and I saw some of that stuff. So, let your brain focus. Are we ready? You ready to focus with me? Okay. So I have I'm going to do a distance one, which is more like collegiate, and then we'll do a profit one, which is a kind of a business calc thing. Okay. So first, what we do is we find our quantity to be optimized. We say, okay, what do I want to ultimately find? And then we label what we know and what I need to find. We're going to have possibly two different equations, a primary equation and a secondary equation. Because if it has more than one variable, you can't solve it with two variables, right? So you have to plug in your secondary equation to put it all in terms of one variable. And that's where you use substitution. You derive your primary equation. That's what you're optimizing. Because what does the derivative give us? It gives us our critical numbers, which yield to a max or min, right? And then we can do our first derivative test, okay? Or you can, if it's easy enough to take the second derivative, this first one won't. I take the second derivative and I test for concavity, and that tells me if it's a max or min as well. You could do that as well. But only if it's easy to find the second derivative, which will be in the next problem. But and then verify with one of those tests that it's a max or min, and then state your answer. Okay, so let's give it a try. All right. All right, first, let me state that this problem could be summarized by, whoops. This problem here could be summarized by asking which points on the graph of y equals 4 minus x squared are closest to the point 0, 2. But I put a situation in here, especially since some of us are going to be meteorologists. All right, you're a meteorologist working to get people as quickly as possible to a safe distance from a hurricane's path of destruction. Your radar predicts that the path of the hurricane and yields a safe zone equation of y equals 4 minus x squared, where people will be safe as long as they get to this boundary line. You can enter coordinates into the system to give you a corresponding GPS location to drive to for safety. If you are located at the point 0, 2 on the XY axis in the system, which points on this safe zone boundary equation are closest to where you are? Give your answer and coordinates. So what I'm asking is to find if I want the closest point, what am I optimizing? I want my minimum distance. Who remembers the distance formula? So let's see. We got distance is the square root of the difference in x's, so x2 minus x1 squared, And then, and yeah, and then the difference in y squared unit goes in between. What goes in between? Plus or minus? It's plus. Difference in x squared plus the difference in y squared. Okay. All right. So example 1.
I'll go to independent problem.
All right. So we, oh, sorry. What am I doing? Y2 minus Y1. Thank you. Good catch. Difference in x squared, Y2 minus Y1. Yeah. Plus the difference in y squared, all under the square root. That's your distance formula. So I want the minimum distance. That is my primary equation. Okay. Now, I want, this is my safe zone equation. I want my distance from points on this equation to 0, 2. So what's the quickest way to get there? So I'm going to write 0, 2. This is going to be my x1, y1. And then my x2, y2 is going to be just like some coordinate on y equals 4 minus x squared. Right? Oh, this is not, I have to point this at the screen because this, I'm trying to record it on here, but it's not showing up. Give me 1 second. Okay. All right. So the next step is to plug things in. So we want to plug in x1, y1. So we got, now, by the way, this x sub 2, I change it to x. Does that make sense? I can call it x minus x sub 1. So that way I don't have to write more than I need. So x minus 0 squared, that's your x1, plus y minus 2 squared. Okay, we good? So x1, y1, 0, 2 goes here. X1, y1. All right. And now, do you see the problem? We can simplify this and say, okay, x minus 0 squared is just x squared plus the quantity y minus 2 squared. But what's the problem here? I can't do that. I have an x and a y. I need to use my secondary equation. What's my secondary equation? You got it. Y equals 4 minus x squared. So that was given in the problem. That's my safe zone boundary, my boundary equation. Y equals 4 minus x squared. So I'm going to plug in for y. This is my substitution step, right? So for this y right here, I'm going to plug in 4 minus x squared. So it's going to look like this.
Just like
D equals x squared plus 4 minus x squared minus 2 squared. Do you agree with that? Okay. So then we simplify. This is now algebra. So we have x squared plus, this becomes 2 minus x squared squared, quantity squared. The quantity of 2 minus x squared squared. I certainly can. Scroll it up. There we go.
Oh.
Okay. Any questions thus far? All right. So now I can make this a little bit easier to take the derivative of, right? How do I do a quantity squared? Do you remember my shortcut? Square double square. Or you can FOIL first outside, inside, last, or square the first, double the middle term, and then square the last. Okay, so I'm just gonna take this out. This 2 minus x squared squared becomes, you square the first, 2 squared is 4. Your middle term would be double. Your middle term is negative 2x squared. So it's going to be minus 4x squared, yes? You square the last. What's your last term? Careful. Positive or negative?
Minus. Positive.
It's positive. You square the negative as well. Think of it because, yeah, think of if you were to actually do this, if you were to FOIL, right? Think about what that last term would be. It would be negative times negative, right? Which is a positive x to the 4th. So this is what we get. X squared plus 4 minus 4x squared plus x to the 4th. And then we can combine our like terms, yes? We have x squared and negative 4x squared. I'm going to write it in decreasing order of powers, so I'm going to write my x to the 4th first. That just makes it easier. So we get x to the 4th. X squared minus 4x squared is minus 3x squared plus 4. Scrolling up.
So.
Questions so far? Are we even going to finish this problem? I'll have to finish it tomorrow. It's okay. All right. So now I have my equation. Can I optimize it?
Yeah, why not?
Yeah, why not? I can take the derivative, yes? So how do we take the we'll call it d prime, okay?
Wait, I have a question. Can't we just take everything out of that square root right now?
Why?
Everything's square. Take out, can't we? That would be like x squared.
You
minus-
can't square a root over addition and subtraction. Good try, but we have to have the painful derivative. So, all right, so this is the, I know. Hey, I'm gonna rewrite. Do you have a question? Okay. I'm gonna rewrite this.
Yeah, because I would lose anyway.
As to the 1/2. Yeah. And then we're gonna take the derivative. So bring it down 1/2 times the chain rule, right? Same quantity inside. Chain rule, right? It's a quantity to a power. Bring it in front, bring the power in front. What do I do to the power? -1. 1/2 minus 1 is 2 over 2 is negative 1/2. So it's to the negative 1/2 times what? The derivative of the inside. Okay. So we have 4x cubed minus 6x. Is everybody so far so good with the derivative? Okay. Then I'm going to rewrite it. Anything to the negative power goes to the denominator. And the 2 is in the denominator. So this becomes like this. All over 2 times.
Because that one is probably.
Equals, and now we're going to set it equal to 0 so that we can optimize, find a max or min.
Never mind, I see it.
Okay. Questions? Okay. So we want to set the numerator equal to 0. We take a GCF, 2x times x squared minus 3. Your answers are x equals 0 and watch this. Wait a minute. Oh, sorry. 2x squared minus 3. I forgot that factor of 2. Okay. X squared equals 3/2, right? So my answer will be root plus or minus 3 over 2. So you guys know I can write this as root 3 over root 2, yeah?
I got 2 actually.
So times, you rationalize it, times root 2 over root 2 is going to be root 6 over 2. Okay, We're okay. All right, so we have 0 in this. Hey, I'm just gonna tell you, we could look on our calculator, but there are no zeros for the denominator, okay?
Yeah.
I'm just gonna save us time. If you put that part, if you put this part in your calculator and you just see it doesn't hit the x-axis, okay? So from here, I've kind of run out of time. We will pick it up here and we were gonna use the first derivative test to see which one of these is our minimum distance. We will pick it up tomorrow. No homework tonight.
They didn't.